Good morning, everyone. In Unit 5, Eigenvalue and Eigen Vector, we already saw type 1, that is non-symmetric and non-repeated eigenvalues. Today we are going to see type 2, type 3, type 4 problems. In type 2, problem based on non-symmetric and repeated eigenvalues. Non-symmetric means your row is not equal to column, that is a given matrix is not equal to its transpose matrix. And repeated eigenvalue, which means in our eigenvalue we get one or two repeated values. See our first problem. Find the eigenvalue and the eigenvector of the matrix A equal to 2 1 1 1 3 1 1 2 2. In the problem itself, we come to know that the given matrix is non-symmetric. See, our rows and column are not equal. Okay. In solution, write the given matrix as it is. There are three steps to solve eigenvalue and eigenvector. In step 1, we are going to solve for characteristic equation. In step 2, we are going to solve for eigenvalue. Using that eigenvalue, in step 3, we are going to find the values for eigenvector. In step 1, we know that the formula for the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Mark this as first equation. In this we have to find the value for s1, s2 and s3. S1 is nothing but sum of the main diagonal elements. Our diagonal element is 2, 3, 2. Add all the things, we get 7. Next, to find the value for x2, s2, sum of the minus of main diagonal elements. We already know that the main diagonal element. So for that, the minus of that element is 3, 1, 2, 2. The next minor of 3 is 2, 1, 1, 2, and the minor of 2 is 2, 2, 1, 3. If we solve this, we get the value for S2 is 11. Mark this as third equation. Next, we have to find the value for S3 is nothing but determinant of A. So, solve for the determinant of the given matrix. We get the value 5. Mark this as fourth equation. Substitute second equation, third equation, fourth equation in equation 1. It is nothing but substitute the value of S1 and S2, S3 value in the given equation 1. So our characteristic equation will become lambda cube minus 7 lambda square plus 11 lambda minus 5 equal to 0. Mark this as fifth equation. This is our characteristic equation. In step 2, we have to find the value for eigenvalues. Put lambda equal to 1 in equation 5. Because our left hand side and right hand side should be equal to 0. If lambda equal to 1 is suitable, then our first root is lambda equal to 1. If it is not suitable, then try for lambda equal to minus 1 or lambda equal to 2, minus 2, 3, minus 3, anything, or else 0. In this, I am going to solve for put lambda equal to 1 in equation 5. So I am substituting 1 for lambda. So while substituting, I get left hand side and right hand side equal to 0. So I am taking the root is lambda equal to 1. This is my first eigenvalue. Next, I have to find another two eigenvalues by using synthetic division methods. See our fifth equation, that is our characteristic equation. Take the coefficients 1, minus 7, 11, minus 5. While solving this, I get the equation lambda square minus 6 lambda plus 5 equal to 0. Using fractional method, I can solve for lambda. So that is lambda equal to 5, 1. Hence the eigenvalues are 1, 5, 1. See here, here there is two eigenvalues are repeated. So I am taking these eigenvalues in step 3. But here there is only two cases. In our type 1 problem, we get three different eigenvalues. So I can find three different eigenvectors using that value. But here two eigenvalues are repeated. So I am using only two cases here. So in step 3, to find eigenvector, we know that the formula for the eigenvector A minus lambda I into x equal to 0. A is nothing but our given matrix minus lambda into I is identity element, that is 1 0 0 0 1 0 0 0 1. X is nothing but x1, x2, x3 equal to 0. So substitute lambda inside, I get the diagonal element will become 2 minus lambda, 3 minus lambda and 2 minus lambda. Mark this as sixth equation. So here we having the lambda value as 5 and 1. So in case 1, put lambda equal to 5 in equation 6. So my diagonal element will become 2 minus 5, 3 minus 5 and 2 minus 5. While solving this, I get the matrix into x1, x2, x3 equal to 0. Now change this as equations. That is, take your first row and the column, multiply it, we get the equation as 7. See, minus 3x1 plus 2x2 plus x3 equal to 0. Then take the second row and the column, x1 minus 2x2 plus x3 equal to 0. Now take the third row and the column, x1 plus 2x2 minus 3x3 equal to 0. Mark this as 7, 8 and 9th equations. Solving 7th equation and 8th equation by using cross rule multiplication, x1, x2, x3, take the middle term, that is 2 as a first one, next 1, then come to the first one minus 3, then mid one 2. Similarly for the 8th equation, center one minus 2, 1, first one, this that is 1, next mid minus 2. Using the cross rule multiplication, I get x1 divided by 2 plus 2, x2 divided by 1 plus 3, x3 divided by 6 minus 2. While solving this, I get all my denominator as 4. So you can divide this by 4. I get 1, 1, 1. Hence the eigenvalue of capital X1 equal to 1, 1, 1. Hence we solved for lambda equal to 5. Next we have to solve for lambda equal to 1. In equation 6, I get the equation. Then multiply the row and column for the 3 equations 10, 11, 12. Here see, all the given equations are similar. So I cannot take 10 and 11 to solve for x2 and x3. Hence put x2 equal to 0 in equation 10. Similarly x3 equal to 0 in equation 10. Hence I can find the value for x2 and x3. See here, put x2 equal to 0 in equation 10. Hence the midterm will become 0. x1 plus x3 equal to 0. Bring the x3 to the next side. That is minus x3. Hence x1 divided by 1 equal to minus x3 divided by 1. Hence the value of x1 is 1 and x2. That is, put x2 equal to 0. So that is x2 value is 0 and the x3 value is minus 1. Hence I find the value for x2, that is 1, 0, minus 1. Similarly, put x3 equal to 0 in equation 10. I can find the value for capital X3, that is 2, minus 1, 0. Hence I find the 3 eigen vectors. This is my type 2 problem. Next we are going to see type 3 problem, that is symmetric and non-repeated eigenvalue. Symmetric is nothing but our given square matrix is equal to its transpose matrix, and a non-repeated eigenvalue, which means my eigenvalue all are different. See the problem. Find the eigenvalue and eigenvector of the matrix A equal to 7, minus 2, 0, minus 2, 6, minus 2, 0, minus 2, 5. In this matrix, my row is equal to its column. That is, the square matrix is equal to its transpose matrix. See here, my first row is 7, minus 2, 0. Similarly, my first column is 7, minus 2, 0. Hence, this is a symmetric matrix. So, I can take the type 3 problem. Given in solution, write the given matrix as it is. In step 1 we have to find for characteristic equation. Step 2 we have to find the eigenvalue. In step 3 we have to find the eigenvector. Step 1, to find the characteristic equation. We know the formula for characteristic equation: lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Mark this as first equation. In this we have to find the value for s1, s2 and s3. s1 is sum of the main diagonal element. My main diagonal element is nothing but 7, 6, 5. Add all the things, I get the value of s1 is 18. Next, s2, sum of the minus of main diagonal element. So first main diagonal element is 7. The minor of 7 is 6, minus 2, minus 2, 5. And the minor of second diagonal element 6 is 7, 0, 0, 5. And the minor of third diagonal element, that is 5, is 7, minus 2, minus 2 6. While solving this, I get the value of S2, that is 99. S3 is determinant of the given matrix. Take the determinant by solving this, we get the value 162. So mark S1 as second equation, S2 as third equation, S3 as fourth equation. Substitute 2, 3, fourth equation in first equation. We get the characteristic equation as lambda cube minus 18 lambda square plus 99 lambda minus 162 equal to 0. Mark this as fifth equation. Next, step 2, we have to find the value for eigenvalue. So first take lambda equal to 1 in equation 5. So my left hand side is not equal to right hand side, that is both the equations are not equal to 0. So hence you can take lambda equal to 2 in equation 5. Similarly, both the left hand side and right hand side are not equal. Put lambda equal to 3 in fifth equation. Hence my left hand side and right hand side are equal. So take the root is lambda equal to 3. So hence I find one eigenvalue, that is lambda equal to 3. By using synthetic division, take the coefficients of characteristic equation, that is 1 minus 18 99 minus 162. While solving this synthetic division, I get the equation as lambda square minus 15 lambda plus 51 equal to 0. Using fractional method, I get the value of lambda equal to 6 and lambda equal to 9. Hence eigenvalues are, so first eigenvalue is 3, then using synthetic division I found the two eigenvalues, that is 6 and 9. Hence 3 6 9. So here all the 3 eigenvalues are different. So this is a non-repeated eigenvalue. Hence in step 3 I can use 3 cases to find the eigenvector. In step 3, to find eigenvector, we know that the formula is A minus lambda I into X equal to 0. A is nothing but our given matrix minus lambda into identity matrix 1 0 0 0 1 0 0 0 1 into X, capital X. So hence we have found the value x1 x2 x3 equal to 0. Substitute lambda into inside, that is multiply. So our diagonal element will become 7 minus lambda, 6 minus lambda, 5 minus lambda, and the remaining element as it is. Mark this as sixth equation. Next, in case 1, put lambda equal to 3. See our eigenvalue, first eigenvalue is 3, second eigenvalue is 6 and third eigenvalue is 9. Take the first eigenvalue lambda equal to 3. Substitute for lambda equal to 3 in equation 6. So we get 4 minus 2 0, minus 2 3 minus 2, 0 minus 2 2 into x1 x2 x3 equal to 0. Similarly form the equation like take the row and the column, multiply it, so we get 3 equation, that is 4x1 minus 2x2 plus 0x3 equal to 0. Next the second row and the column minus 2x1 3x2 minus 2x3 equal to 0. Now third row and the column 0 into x1 minus 2x2 plus 2x3 equal to 0. So mark this as 7th, 8th and 9th equation. By solving 7th and 8th equation by using cross rule multiplication, I get minus 2. So in the 7th equation, take the mid value, next value, first value, mid value, that is minus 2 0, 4 minus 2. Similarly for the 8th equation, 3 minus 2 3. Now x1 divided by minus 2 into minus 2 is nothing but 4. Formula minus into 0 equal to x2 divided by 0 into minus 2 is 0. Formula minus and there is minus sign in 2. So plus 2 into 4 is 8. Then x3 divided by 12. My formula minus, here minus 2 into minus 2 is plus 4. So minus 4. So x1 divided by 4, x2 divided by 8, x3 divided by 8. All the three things are divided by 4. So my equation will become x1 by 1, x2 by 2, x3 by 3. X3 by 2. Hence the eigenvectors of x1 is 1, 2, 2. Next, in case 2, put lambda equal to 6 in sixth equation. So our second eigenvalue is 6. So similarly, substitute for lambda equal to 6 in your diagonal element. So diagonal element will become 1 0 minus 1. The remaining element as it is form the equations 10, 11 and 12. Solving 10th and 9th equation by using cross rule multiplication, I get the value of x1, x2, x3 as 4, 2, minus 4. All the three things are divided by 2. So divided it, I get x1 by 2, x2 by 1 and x3 by minus 2. Hence, I can say the eigenvector of capital X2 is 2, 1, minus 2. In case 3, my third eigenvalue is 9. So put lambda equal to 9 in sixth equation. Our diagonal element will become minus 2, minus 3, minus 4. Hence form the equations minus 2x1 minus 2x2 plus 0x3 equal to 0. Mark this as 13th equation. Next 2x minus 2x1 minus 3x2 minus 2x3 equal to 0. Mark this as 14th equation. 0x1 minus 2x2 minus 4x3 equal to 0. Mark this as 15th equation. While solving 13th and 14th equation by using cross rule multiplication, I get the value x1 divided by 4 equal to x2 divided by minus 4, x3 divided by 4. All the three values are divided by 2. Hence x1 divided by 2, x2 divided by minus 2, x3 divided by 1. Hence the eigenvector of x3 is 2 minus 2, 1. Hence I find the value for the given matrix in symmetric and non-repeated eigenvalue. This is our type 3. Next, type 4. Next problem based on symmetric and non-repeated eigenvalue. Symmetric, we already know that our square matrix is equal to its transpose, that is symmetric. And repeated eigenvalue, our eigenvalue one or two element will become repeated. So in this we are using orthogonal vector. There is nothing but let the eigenvector. Here we are using orthogonal vector. It is nothing but the formula for this is x1 transpose into x2 equal to 0. In this I can find the value for x2 x3, x3 x1, x3 x1, similarly vice versa. Now the problem given here is find the eigenvalue and the eigenvector of the matrix A equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. See here, my given row is equal to its column, that is 6 minus 2 2 is first row, and take the column 6 minus 2 2. Here our square matrix is equal to its transpose, so I can easily say that the given matrix is symmetric. In solution, write the given matrix as it is. Next, to find the characteristic equation, my formula for the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Mark this as first equations. In this we have to find the value for s1, s2 and s3. s1 is nothing but sum of the main diagonal element. In this main diagonal element is 6, 3, 3. Add all the thing, I get the value of s1 is 12. s2 is sum of the minus of main diagonal element. Here the minor elements are, first one is 3 minus 1 minus 1 3, and the second one 6 2 2 3, and third one 6 minus 2 minus 2 3. While solving this, I get the value of S2 equal to 36. Then S3 is nothing but determinant of the given matrix. While solving this, I get the value of S3 is 32. So mark S1 as second equation, S2 as third equation, and S3 as fourth equation. Substitute all the values in my first equation. So I get the characteristic equation as lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. Mark this as fifth equations. Hence we find the value of characteristic equation. In step 2 we have to find the value of eigenvalue. So put lambda equal to 1 in equation 5. My left hand side and right hand side are not equal. Hence move on to lambda equal to 2 in equation 5. Hence left hand side and right hand side both are equal to 0. So I can take the value of lambda equal to 2. So this is my first eigenvalue. Next, by using synthetic division, so in the characteristic equation take the coefficients 1, minus 12, 36, minus 32. While solving this, I get the equation lambda square minus 10 lambda plus 16 equal to 0. Hence using fractional method, I get the value lambda equal to 8 and lambda equal to 2. Therefore the eigenvalues are 2, 8, 2. So first 2 is nothing but First we saw left hand side and right hand side equal to 0, so take that value lambda equal to 2. Now you after substituting in fractional method, I get two values 8 and 2. So here my eigenvalues are repeated. See, you both the symmetry and eigenvalues are repeated. We can use type 4 formula. Next, in step 3 we have to find the eigenvector. We know that a minus lambda I into x equal to 0. A is our given matrix minus lambda into identity element. Solve the equations, we get the sixth equation. In case 1, so lambda, take lambda equal to 8 in sixth equation. So my diagonal element will become minus 2, minus 5, minus 5. Solve for the equations 10, 11 and 12. We already know that using cross rule multiplication, take 10th equation and 11th equation. So we get the value of x1, x2, x3 is nothing but 12, minus 6 and 6. So all the three values are divided by 6, hence divided it. X1 divided by 2, x2 divided by minus 1 and x3 divided by 1. Therefore the eigenvalues are 2, minus 1, 1. Next, in case 2, we have to find the value for lambda equal to 2. Substitute lambda equal to 2 in diagonal element and solve for the equation 9, 10 and 11. In this, put x2 equal to 0 in ninth equation. So 4x1 minus 0 plus 2x3 equal to 0. Take this 2x3 to next side, it will become minus 2x3. So in both the sides we can divide it by 2. So 2x1 equal to minus x3. So x1 divided by 1 equal to minus x3 divided by 2. Here the value of x1 is 1, x2 is 0, x3 is minus 2. Hence the eigenvector of x2 is 1, 0, minus 2. In case 3, by using orthogonal formula, x1 transpose into x2 equal to 0. So I am using this for symmetric and repeated eigenvalues. Here I am taking x3 equal to L, M, N in column wise. If I take transpose of this x3, I get L, M, N in row wise. Next, by using the formula x3 transpose into x1 equal to 0, x3 transpose is nothing but take the transpose of L, M, N, it will become row. And I know that the value of x1, that is the eigenvector x1 is 2, minus 1, 1. Multiply both the terms, I get 2L minus M plus N equal to 0. So mark this as equation A. If x3 equal to 0, orthogonal to x2. Now take x3 transpose value and x2 value, that is 1, 0, minus 2. Multiply both the terms, I get L plus 0m minus 2n equal to 0. Mark this as B equation. While solving this A and B using cross rule multiplication, I get the value 2, 5, 1. Therefore the eigenvector of x3 is 2, 5, 1. Hence we find the value of eigenvector. Thank you.